Hello, hello, hi everyone. If you could please make your way to a seat. Hey, can you do me a favor? If you have an open seat next to you, can you just give a little wave? Okay? So those are all the new friends that you can make over there. So if you're looking for a seat, this is the chance to make a new friend at the start of this quarter. So anyways, yeah, so we're going to go ahead and get started.
All right, yeah. Oh, wow, this is crazy. Maybe we should turn that down. Okay. Well, if you're wondering who we are not the speaker tonight, but just as a brief introduction, my name is Javon. I'm a computer science master's student here at UW, and I'm a researcher and instructor also.
My name is AJ. I'm a software engineer by day, and by night, I volunteer as a spiritual mentor for A2F Fellowship in Klesis. We're the Christian organization that's hosting this talk. We're super stoked to be here together tonight, so glad you could all make it out and spend your Friday evening with us.
Yeah, and tonight we're going to be hearing from Dr. Brian Miller, so a little bit more about him and his credentials.
Okay, let me just pause here because I want to brag about him real quick, okay? So Dr. Miller, he did his bachelor's in physics with a minor in engineering at MIT, okay? And as if that wasn't awesome enough, he went on to do a Ph.D. in physics at Duke. And as if that wasn't awesome enough, he is now a research coordinator and senior fellow at the Discovery Institute, which is here in Seattle. So a couple other really cool things. He's been in many scientific meetings with leading origin of life theorists. He's collaborated with a very prominent physicist, Jeremy England, in the journal Inference Review. So this man has like way more IQ points in like his left pinky than like my entire body. So he is a smart man, and I'm really excited to have him here tonight.
Yeah, and the topic that he's talking about is particularly special. It's significant, really, because this answers the question that we should all be thinking about, because whether or not science disproves or proves God determines how we should live our lives and the way that we're going to live our lives in the future. And so I had the exciting opportunity to listen to Dr. Miller earlier this year, and I think something that particularly impacted me was the fact that he really just aims to seek truth. He's not afraid to just seek the data and then follow where it leads, and I think that's something that we can all take for our own lives. So yeah, just come into it with open ears, open minds, and
So real quick, I want to lay out like what the roadmap is going to be for tonight. So we're going to leave soon and take our seats so that Dr. Miller can come up. He's going to go through his talk. Afterwards, I'll come back up for a quick little pause because we're going to shift gears to a live Q&A. So there's going to be two microphones, one on each side, okay? And that is your opportunity to ask questions. So as you're listening, as you're hearing things and you're like, I want to ask more about that, or I'm kind of wondering about that, take a mental note, write it down on your phone, tell your friend like, hey, that was interesting, I want to ask about that, remind me later, and if they're a good friend, they'll help you out, right? So you'll have an opportunity to come up here and ask those questions. So I'll come back up to facilitate that time. So should we get off?
yeah, let's go. With that,
right.
we'll welcome Dr. Brian Miller to the stage.
Woo!
Thank you. It's always strange when you hear people read your bio, like they're talking about you and you're right there. It's kind of odd. I remember I was in a meeting once with my friends, and they were reading my bio, and my friend next to me says, that person sounded really impressive, and I realized it was just you. So I apologize, but it's just me. But it really is an honor to be here, because the first time I spoke at University of Washington on faith and science was 1998. Who was alive back then? Okay, that's encouraging. Okay. But this really is a topic very dear to me, because when I was a freshman at MIT, it was a place where my future looked really bright. I'd probably get a really nice job. I was at a top university. And then suddenly, I started to think about, well, this is nice, but what is the purpose of life? Like, if I'm about to die, what difference does it make? If it's 80 years or 100 years or 50 years, what difference would it make once I cease to exist? I mean, it was pretty deep thoughts as a freshman, but that was kind of where I was. Oh, not working?
It's a little static.
Okay. Let me turn. Testing. How's that? I have this really bad habit that I talk with my hands. So if you can't hear me, just yell. yell, speak up, okay? So I'll bring my hand back. But what happened when I was a freshman in college was I was raised believing in God or a creator. And I went to MIT undergraduate. And my freshman year, what happened was I was really challenged by people that had all sorts of different backgrounds than myself. I took a class on the Bible taught by someone who was an agnostic or an atheist, who argued that religion was really just sort of a psychological crutch. I read Richard Dawkins, and if you're not familiar, who's familiar with Richard Dawkins, by the way? He's pretty famous. He's considered one of the patron saints of atheism. He was at one time called one of the four horsemen of the apocalypse for religion. And what happened was when I was at MIT, I read one of his books, and his book was called The Blind Watchmaker. And the thesis of his book was that when you look at nature, everything you see is simply a product of the blind forces of nature. There is no purpose, there is no design. His thesis was basically that nature is pitiless and indifferent. And what happened is through those experiences as a freshman, I became pretty convinced that religion was a psychological crutch. I became pretty convinced that there were really two basic types of people in the world. One person was a person of science. They were rational, they were logical, they'd study the evidence. And then you had people of faith. They were more emotional, kind of fluffy, they just sort of believed things blindly. And I was a person of science. I was studying physics. And I just remember I went up to my room and I said, God, I don't know if you exist, but if you do exist, you have to prove it to me. I don't know if that's against the rules, if it's not the way it's supposed to happen, but I'm a scientist. I just can't do this blindly. And what happened is I said, God, if you are real and you prove to me what's true, then I will follow you with all my heart and serve you all the days of my life. And what happened is that put me on a journey, which was partly intellectual, where I studied science, biology, chemistry, physics, comparative religions, history of the New Testament, different things like that. And what happened is over the period of several years, I came back to faith. And part of my coming back to faith was this intellectual journey of looking for evidence of God. Part of it was encountering God in more supernatural ways, which are much harder to articulate in an objective fashion. So I'll focus on the science. But what I realized through my journey is that often a little science takes people away from God, but a lot of science will typically bring them back. And that's a famous quote. I don't know who it's from, but it's a very famous quote. And I think it's very powerful because many people have this impression that there is this hopeless divide between faith and science. They've embraced what's called the warfare myth, this idea that faith and science has always been in conflict. I'm about to show you that none of that is true. So what I'm going to do is give you a very, very small taste of the evidence that really has shaped my understanding of this conversation over the last 35, 40 years. And then I'll give you a website which will have a lot more evidence. So you just get a little bit of the evidence today. It's kind of like before a movie, you see lots of trailers. That's what it's going to be like. So I'll try not to go too fast. But during the question and answer, we can focus on things in more detail. But going back to my story, what I realized was that my perspective was not unique, because I realized if there was no God, if we were just an accident of nature, there really was no purpose. And you have other people, for instance, Lawrence Krauss, and Lawrence Krauss is a bit less known than Richard Dawkins, but he wrote the book, A Universe from Nothing. And he said that we constitute a 1% bit of pollution in the universe. We are completely irrelevant. He probably won't be your graduation speaker anytime soon, but this is just kind of reality, right? Because I think what's fascinating about people often is they don't really think about what is the purpose of their life? What does eternity have in store for them? Because what happens is we kind of just medicate ourselves. We get distracted by doing our work or video games or whatever, and it kind of numbs this existential pain in our heart. And for me, I just couldn't do that. So for me, it was this exploration of what is actually true. And the area of science is one of the most significant, because what you find, one, is that the evidence of design in every field of science is overwhelming, and I'll show you some of that. But two, what's fascinating is that this debate is not new. A lot of people think the debate about design in nature or biology goes back to the Scopes monkey trials in Tennessee, or it goes perhaps back to Darwin, but it actually goes back to about 500 BC, where you have Greek philosophers, people like Democritus, who advocated materialism. Oh, and you're a pretty savvy crowd, so I know when I say materialism, you're not thinking like Madonna, a material girl. It's like lots of bling and cars. And when I say materialism, I'm talking about the philosophy that everything is simply a product of material processes. It's just matter and forces, chance and time. That's what I say when I say materialism or materialist or scientific materialism. That's what I'm talking about. The philosophy that all that exists is matter, energy, chance, and time. And of course, they were debating people like Plato, people like Aristotle, people like Socrates, who argued that, and I'm going to explain this in grossly simplistic terms, so I apologize for you philosophers who probably have a heart attack. But just in very simple terms, they advocated design. They said that there's a mind behind our universe. And when you look at nature, you look at life, you look at our planet, particularly when you look at the human body, it points to a rationality, a telos, a logos. It points to there being a creator, a mind behind our universe. And then this debate carried on for centuries. In fact, around the 1st century BC, there was a poet named Lucretius, a Latin poet and philosopher, and a Roman poet and philosopher. He wrote a poem where he talked about how all life may look designed, but it's really not designed. What you have is this ethereal realm where there's lots of body parts floating around, and they randomly come together in different ways. And some are fit, so they survive, and some are not fit, so they don't survive. So what you see is sort of a primitive version of natural selection back in the 1st century BC. In fact, what's really remarkable is if you look at Charles Darwin, near the end of his life, he recognized and acknowledged that his ideas of adaptation and heredity were essentially the same as Hippocrates. So they simply go back to the ancient Greeks. So these conversations that we think are very modern are actually very, very ancient. Well, what happened is during the Middle Ages, belief in design dominated the Western Europe. They dominated the Western culture. And this atomistic, materialist view died out almost. What happened, though, is when you have the rise of modern physics, people like Newton, people like Galileo, what people eventually realized, just a second. This is always like, it's one of those dreams where you wake up and, yeah, okay, good. What they realized is that you could explain so much in nature with simple equations. Like you could write down on a napkin equations that would describe practically every process in our universe. Things like Schrödinger's equations, Maxwell's equations, things like the field equations. And they said this really creates more credibility for this materialistic idea of reality because you can really explain so much in terms of matter in these rules between the atoms, rules of matter. However, that didn't necessarily challenge the view of design. In fact, if you look at the early scientists, the people that created the foundation of modern science, particularly physics, they were largely Christian. They largely weren't just simply religious, but they were deeply religious. And it was their faith that really inspired them to do science. Because if you want to study the world, you have to believe that the world is orderly, and you have to believe that we have the mental capacity to understand that order. And that was very foundational in their Christian belief, because they believe that God created the universe. In the same way he gave moral laws, he gave physical laws, and because we're created in his image, we have the ability to understand the order that God created. So what you find is that most of the founders of modern science were inspired by their faith to understand the world. That's just kind of where they were. But of course, that changed a lot during more of like the 1800s. What took place in Europe, and again, this is grossly simplistic because if I were to do it right, I'd go back to like more like the 1400s, but we won't go there. What happened though is you have a lot of philosophers that came on the scene, people like Voltaire, people like Hume, people like Spinoza, who were just really much more skeptical about this idea of the God of religion, the God of the church at that time period. And the philosophy of that time was sort of moving away from the idea of a creator And at the same time, Darwin came up with his idea of evolution, where he essentially renounced teleology, which is the idea of purpose. He argued that when you look at life, it's not design, it's simply the product of blind, undirected processes that have nothing in mind. So what you find is with the philosophers of that time period and with Darwin, design was basically pushed up to the sidelines. It was essentially removed from the conversation. And then today, if you go to your typical university, like University of Washington, it's almost, if you talk about there being design in nature, or particularly design in life, people actually have panic attacks. And I've actually seen this at conferences. So there's this enormous opposition to this idea of there being a designer. Until now. I'm being overly dramatic. Until recently. What happened is what you find is that there's been shifts taking place in the scientific culture. Because before, if you go back several decades, the scientific culture was a lot like this. And this is Richard Lewontin. He was a biologist at Harvard. He gave this very famous quote. He said, "Our willingness to accept scientific claims that are against common sense is the key to understanding of the real struggle between science and the supernatural. We take the side of science in spite of the patent absurdity of some of its constructs, in spite of its failure to fulfill many of its extravagant promises of health and life, in spite of the tolerance of the scientific community for the unsubstantiated just so stories, because we have an a priori commitment, a commitment to materialism." So again, if you go back a few decades, the idea was that we assume on faith that everything must be the product of natural processes. We will accept any theory, no matter how crazy, any idea, no matter how seemingly absurd, if we have to in order to deny the possibility of design. That's where we were. What's happened, though, is the science is pushing in the direction of design so strongly that this perspective is shifting. One of the big discoveries was with Einstein, because you have Einstein who came up with general relativity. For those of you recognize this as the field equation. Okay, I'm sorry. For those of you with a physics background, you recognize that as the field equation. And what happened is Einstein realized is his understanding of space and time and their interactions meant that the universe looked like it had to be either expanding or contracting. That bothered him because physicists at the time believed that the universe was eternal, and that's important. It goes back to the ancient Greeks, Democritus. Because if the universe is eternal, you don't have to explain the origin of matter because it was always here. Because it doesn't, oh, and this gets into one of the questions that someone asked during I think at one of the booths. The question people often ask is, well, if God created everything, who created God? Do you ever think about that? The reality is something must fundamentally exist. It doesn't matter what you believe, you have to believe something just is. It's eternal. It's something that you can't explain. It's always there. And for the materialist, what's always there is matter. So what happened is when Einstein came up with his equations, he said, wait a minute, this suggests that maybe matter wasn't always there. So what he did was he added what's called the cosmological constant. And that's that little lambda there. Now that's fine. That lambda isn't problematic because it falls out naturally from the math. The problem, though, and just as a side note, I can't resist telling you this, that's what's called dark energy. That's sort of this idea that there's an energy permeating space, and that energy that permeates space pushes space apart. So gravity pulls space together, dark energy pushes it apart, and he set that constant perfectly to balance out those two forces so that he could have a static universe. Completely arbitrary. Unfortunately, what happened is people started to realize when you look at the universe, you see what's called a redshift. Because when galaxies move away from us, the light looks like it has a lower frequency. It's kind of like when a train goes by and the sound sounds like it's a lower pitch. It's the same idea. So the redshift of galaxies far away told him and others, like people like Hubble, that the universe is expanding. So then he realized that he was wrong, and he said, that was the greatest blunder of my life, because Einstein could have predicted the Big Bang if he wasn't philosophically opposed to the universe having a beginning. But what they realized is that the universe, from all that we can tell from the laws of nature, does have a beginning. Time, space, matter, and energy all began. The Big Bang is not a big explosion in space. The Big Bang is everything begins. Time, space, matter, and energy. So whatever started it has to be immaterial, outside of time and space, and infinitely powerful, which sort of sounds like a creator. So again, people, when they saw this, you see atheist professors, atheist physicists starting to believe in a creator because their atheistic framework was shattered by general relativity. But that's something even more striking, is as physicists have studied the laws of nature, what they realized is the laws of nature looked like they were designed for the purpose of supporting life. And a good analogy for this is a mixer board. Any musicians in here? Musicians? If you're a musician and you have a mixer board, you can control all these various dials which control, I don't know what they do, I'm not a musician, but if you were gonna randomly turn those dials, what would the sound like? Not very good. You have to set every dial right so all the sounds are in the right frequency. In the same way, imagine that this is a gift that creates universes. You can create any universe you want, and you can set the dials however you want. If you turn this dial, gravity gets stronger, you feel heavier. You turn the dial the other way, you feel lighter. You turn this dial, the mass of a quark goes up. You turn it the other way, the mass of a quark goes down. This dial controls the early disorder in the universe, et cetera, et cetera. If you were to set those dials by chance, there's virtually no chance you would have a universe that supports life. All the universe would be is a bunch of particles floating in space or a bunch of black holes. That's a huge challenge. One example is if you look at the force that holds protons and electrons together, the electromagnetic force or the electric field, or however you want to describe it, if that were just a few percent higher or a few percent lower, there would be no life in the universe, because you have to set the force that holds electrons and protons together, and you have to set the force right which holds the nucleus together. That's a strong nuclear force. If either of those forces were a few percent higher or lower, the universe would not support life because we would not have large amounts of carbon and oxygen, which are essential for life. We would just have a bunch of simple elements like hydrogen and helium, maybe some lithium, but no complex molecules that are essential for life. So again, this was shocking. In fact, Fred Hoyle, he actually, interestingly enough, Fred Hoyle was an astrophysicist who came up with the term the Big Bang. But he came up with it as a ridicule because he did not like the idea of the universe starting, so he said, oh, you believe in a Big Bang? But it kind of stuck. Fred Hoyle, ironically, also realized that these forces have to be carefully set or there can't be life. And he said, this evidence is very problematic. But it gets even worse, because if you really think about it at a deeper level, and you ask yourself, what is the range that these forces could have? A good example is gravity. And people imagine that any force could potentially be anywhere from 0 to the strong nuclear force, which is the strongest force. Well, given that's your range, to set gravity in such a way that you can allow for life, it has to be set to 1 part in 10 to the 35. That's a 1 with 35 zeros. Anyone here shoot guns, by the way? Not that I think you're going to hurt me, I'm just kind of curious. How far would it take for you to hit a target? How far away do you think you could hit a target which is about that big, like a centimeter in width? How far? Yeah. That's really good. That's impressive. Not Jason Bourne, but it's still really, really good. the precision you would need to set gravity to support life would be like hitting a target, which is a centimeter, at the other end of our solar system. That's the precision you would need to set gravity just right to allow for life. It gets even worse. This is, again, I told you about the cosmological constant. You would have to set that right to 1 part in 10 to the 90. That's like hitting the target halfway across the visible universe. And the disorder in the universe, the fact that we've got stars and planets means that the universe had to start incredibly ordered. The chance of getting that right is like 1 chance in 10 to the 10 to the 123. If you were to write that number, you'd have to write a 0 on every single particle in the visible universe, and it still wouldn't be enough. So again, what people realized is that there's something about our universe that is not an accident. Fred Hoyle said, a common sense interpretation of the data suggests that a super intellect has monkeyed with physics as well as with chemistry and biology. He was an atheist, but rumor has it that this evidence shook his atheism to the core. So that was really striking. Now, have you ever heard of the multiverse? Of course you have. You watched, either was it Doctor Strange or whatever. The response has been interesting because what you see is a universe that shows design. But remember, I read that quote from Levantin that we'll accept any explanation to avoid that. So people said, maybe we've got lots and lots of universes out there, and every universe is slightly different, and we just won the lottery. We just happen to be in the universe that allows for life. Problem, because to have a multiverse, you've got to have a multiverse generator. You've got to have something that creates universes. And there's a lot of mechanisms that people appeal to, things like eternal inflation, things like string landscape cosmology, things like quantum cosmology. But when you look at all these machines that generate universes, they also have to be fine-tuned to work. So to have a multiverse generator like an inflationary field that produces lots of universes where one could support life, it has to be finely tuned as much as the universe itself. So it's kind of like if you have a carpet and you have a big bulge in the carpet, what do you want to do to that bulge? You want to step on it, but what happens to the bulge? It appears someplace else. In the same way, every attempt to create a theory to explain away the fine-tuning, it also has to be fine-tuned. That's the challenge. But it's not just with the universe. When you look at our planet shows countless details that point to a mind, that point to design. To have a planet that supports life, you've got to have the right sun that produces the right energy. You want it to be stable. You want it to produce heat and light. You don't want it to produce lots of X-rays or microwaves. That would be bad. Our sun does what we need. You also have to have an atmosphere. And that atmosphere has to let in the right sunlight, the right energy. This is a graph that shows the energy that penetrates our atmosphere. And you notice this little hole right where you've got visible light and heat? That's exactly where you want it for a planet to support life. Interestingly enough, water is the same way. Water allows light and heat to penetrate, and it blocks X-rays, microwaves, and all the harmful radiation. So you see this beautiful convergence in the laws of nature, in our atmosphere, in our planet that allows for life. You could talk about our magnetic field. What happens is our magma in our planet rotates. That rotation produces a current, which produces a magnetic field. If that magnetic field were not there, we wouldn't have life on Earth because charged particles from the sun would kill us. So we have to have that to have life. Remarkably, our atmosphere has the perfect chemistry so that when the radiation from the sun hits it, it produces ozone in just the right amount that protects us from UV radiation. Plate tectonics. You have to have plate tectonics to recycle things like the carbon dioxide and other materials, because without plate tectonics, life could not exist on our planet for long periods of time. If you think about our planet Jupiter, what happens with Jupiter and Saturn, we've got these large planets in our solar system. If they were not there, we'd have lots of problems because we'd be hit by asteroids, and that doesn't go well. So these planets act like vacuum cleaners, which attract all the large materials to protect us. Again, essential for life. But it isn't just that our planet appears designed for life. It appears designed for scientific investigation and cultural advancement. Our planet atmosphere happens to be transparent so that we can study the stars. We happen to be in the perfect place in our solar system to see the solar system. We're between these spiral arms. If we're in a spiral arm, it would just be dust and light. It just so happens that our magnetic field helps us to navigate the oceans. But what's really fascinating is fire. Because not only is our atmosphere have the perfect amount of oxygen for us to breathe, because if we had too little oxygen, we couldn't be very energetic. If we had too much oxygen, the oxygen would cause our body to decompose like a rotten apple core. But it's just the perfect amount of oxygen and nitrogen for fire. Because if oxygen had different properties, or we didn't have enough oxygen, or we didn't have enough nitrogen, something would be very problematic. Either we couldn't produce fire because there's not enough oxygen, or the fire would burn down all our forests. But what happens is we have just the right amount to produce fire in a way that's highly controllable, and that allows for technology, because you have to have fire to melt metals to create tools. And fire also helps us to do lots of other useful things technologically. Another beautiful example is high acuity vision. Because if you look at the wavelength of light that penetrates our atmosphere, it's the wavelength of light that photoreceptors can detect because it reacts with the ritalin. It reacts with the protein. What happens is that wavelength is perfect for the optics of the eye. Because if you look at the size of an eye, the wavelength of light causes it to produce a high-resolution image at just the right place. Because if the wavelength of light were much longer, eyes would have to be the size of football fields for us to be able to see clearly. And if it was shorter, it would not work out so well either. What's also amazing is it just so happens that the photoreceptors have to be a certain size to detect photons in low light. You have to have enough room for all the molecules, the photoreceptive molecules. It just so happens that the highest resolution possible based on the size of the photoreceptors matches the resolution possible based on the wavelength of light and the optics of our eye. So you see this convergence of design in the laws of nature, in biology, in chemistry, and so forth. Also, what's amazing is if you look at our planet, isn't it convenient? We have all these nice gold and silver and uranium and all the stuff right near the surface. Isn't that nice? What happens is because of plate tectonics and other details of our planet, it allows for the high accumulation of precious metals and resources near the surface of the planet, and even life, bacterial mats, will super concentrate a lot of the materials that are useful for technology, things like gold. So again, it's remarkable that our planet is designed for technology, which is for us. In fact, what's also amazing is if you look at the laws of nature and our planet, it just so happens that technology can increase step by step by step. So we can create simple stone tools with no technology. Those stone tools help us to do things more advanced. It helps us to get simple forms of energy like burning wood. That leads us into the next level of physics, which would go from mechanics to things like electromagnetism and electricity, which allows us to get even to access other forms of energy like oil. That eventually leads to our understanding of the atom, which is atomic physics, and that eventually leads to our understanding of subatomic physics. So what you find, remarkably, is that our universe appears to be designed so that our ability to access one form of energy and one form of knowledge leads to the next form of energy and the next form of knowledge all the way up, where we can go and eventually explore the moon. So that's just something very interesting, and a lot of other philosophers have talked about that. And of course, human body is perfectly designed for us to be technological. We've got advanced hearing, we've got advanced vision, we have upright posture, We've got incredible dexterity in our hands. We've got language centers. Oh, and that's something we take for granted, that we can hear things and speak. That's not easy. We have highly specialized neurons that go from our hearing center to our vocal cords, which allow us to speak. Chimpanzees can't do that. Parrots can, and it's interesting enough, parrots have very similar neural wiring than we do, but it so happens that we've got these mental capacities like language, higher reasoning, reading and writing that allow us to advance technologically. We're perfectly designed for that. So you see this convergence of design from physics to chemistry to biology to atmospheric studies to our planetary system. Now, of course, the one issue that's always been the most controversial is the issue of life. Is life the product of undirected processes, or is life the product of a mind? This is my specialty, by the way. I have a Ph.D. in complex systems physics. I've had a chance to dialogue with some leaders in the field. In fact, I wasn't actually a collaborator with Jeremy England, but we had very good correspondence in the journal Inference. But I've been able to read the latest research, and what's very clear is biology shows evidence of design that is indisputable and clearly discernible. And let me explain that to you. Let's talk about life. Now, first of all, we have to ask, how do people try to explain life through a natural process? And I'm not criticizing origin of life researchers. They're very honest people. They have integrity. They're operating within their materialist worldview. So they assume that life must have originated from natural processes. So they do the best they can to understand that. That's fine. I'm not criticizing them. But if you step outside that worldview and you ask, what does the evidence really show you? It shows you that life did not happen as an accident. Let's just kind of go through this. Any origin of life theory is going to start with producing the basic building blocks of life. Simple sugars, fatty acids, amino acids, which produce proteins, nucleotides, which produce DNA and RNA. There are 20 amino acids that are common. There's a couple others that occasionally appear. There's 4 nucleotides, A, C, T, and G is the designation. And what happens is the first step is you have to get the basic building blocks. Then what has to happen is you have to put them, or the basic molecules, that then create the brick and mortar of cells. The nucleotides become DNA and RNA. They form long chains. Amino acids form proteins. This is kind of like a sentence. These are like letters in the alphabet. There's 20 amino acids, like 26 letters. These have to arrange properly in the same way letters have to arrange properly in a sentence for it to make sense. Same idea. These form the cell membrane, phospholipids, which are part of fatty acids, and then you've got the simple sugars that have all different roles in the cell, including supporting the cell membrane. So what happens after you have the building blocks is you have to put them together into a system, and then eventually it has to develop into a fully functional cell. That's the idea. How far have people gotten? Well, I'm sure you've heard of the Miller-Urey experiment. This is the famous experiment you'll read about in any textbook, where they took gases they thought might have been on the early Earth, shocked it with electricity, and then they got an output. And what did they produce? They produced tar, asphalt, gunk. That's it. That's origin of life research right there. So what happens, if you look at studies, whether it be simulations, whether it be doing things like mass spec, whatever they do, to look at what's in this gunk, is you always will see vast numbers of molecules. In fact, they've even done simulations where they said if we start with basic molecules on the early Earth, what sort of molecules do you get after several generations? What you find is you get billions of molecules over time. In this particular study, they found that 0.2% of the molecules produced were useful for life. 0.2%. And those are the simpler ones. So what you find is this is where all origin of life ends, right here. Because you have this soup, you've got some things that are kind of useful for life, like some amino acids, perhaps some ribose, but they will never link into chains because there's too many other molecules that'll interfere with the reaction. This is where all origin of life ends, right here. But that's just the start of the problem. Let's ignore all that. Let's just pretend that's not a problem. let's imagine it's really easy to get proteins and RNA and DNA. Here's the other problem. If you imagine you've got a small pond and you've got a cell membrane and you've got everything you need in a cell, it's all there, ready to go. All it needs is one protein. Then you got a fully functional cell. And that protein happens to be in the same area. This is, let's say, a cubic meter of water, like a small pond. It would take millions of years, potentially, for that protein to even find the cell membrane based on diffusion. A protein may last a month, if you're lucky. If we want to be generous, let's say a year. Everything is going to break apart. So this localization problem that nobody talks about, practically, is an insurmountable problem in this scenario. But of course, let's ignore that. Let's pretend that's not a problem. Let's imagine you've got everything you need for a cell right there, all the proteins, all the nucleotides. I'll give you the cell membrane. Well, the problem is, how do you assemble it? Because what people have found is that if you just simply take like a yeast cell, the number of ways you can just interconnect the proteins is like 10 to the 79 billion. That's a 1 with 79 billion zeros. The vast majority are not going to be life. Only a fantastically small percentage will be life. And if you kind of say it's not a yeast cell, but let's say it's a lot simpler, let's be generous, 10 to the million. That's only a 1 with a million zeros. There is no chance you're going to put together your proteins properly to have life. It's not going to happen. But the big challenge is thermodynamics. No one had felt a panic attack with thermodynamics and physics. We're okay? Just wanted to make sure. But thermodynamics is basically the science of energy and work and heat exchange. And what you find is that natural processes, let me just do that again because it's a nice animation, always take life and break it apart into simpler, disorganized molecules. Natural processes never take simple molecules and move it in the direction of life. It can't happen. And let me explain to you why. I'm going to explain to you a whole semester of thermodynamics in 2 minutes. Isn't that exciting? You can just tell your professor, hey, I'm good. I don't need it. Just give me the test. All natural processes will tend in 2 different ways. They'll either go from order to disorder. I don't think I have to. Now, how many of you really have trouble keeping your room messy? You really try, but you come back and it's always, no. Why is that? Because there's so many more ways to have a messy room than a neat room. And to make it even simpler, here's a simple example. If you've got 4 atoms or 4 balls and you've got this system of 2 spheres, there's a lot more ways to have 2 on one side and 2 on the other than have all 4 on one side. This is greater entropy because it's more probable. It's greater entropy because there's more ways it can happen. That wasn't hard, was it? It's not mysterious. So you might ask a question, does entropy always spontaneously increase? Usually, but not always. Let me give you an example. What about this? When water cools, it becomes ice. But ice has more order, lower entropy than water. Well, how does that happen? Here's how it happens. Because you've got the forces that will attract the oxygen to the hydrogen. So what happens is when water becomes ice, it's a lower energy state. It wants to go in that position, so it gives off heat. Heat goes into the environment. And what happens is the system may go to lower entropy, but heat goes into the environment, so the entropy of the environment goes up more than the entropy of the system goes down. So the total entropy goes up because of the heat going to the environment. Make sense? That's how it works. But there's a problem. Here's the problem. Origin of life requires a system to both decrease in entropy and increase in energy, which never occurs spontaneously since the total entropy would decrease. The origin of life is a physical impossibility without something helping it. That's a challenge. This is one of the leading origin of life researchers. I met him in a conference, very nice man, Steve Benner. In his paper, Paradoxes in the Origin of Life, he says, chemical theories, including the second law of thermodynamics, technical babble, suggests that it is impossible for any non-living chemical system to escape devolution and enter into the Darwinian world of living. He's an atheist, I think, an agnostic. He is absolutely convinced that life originated through a natural process. He is as knowledgeable in the field as anyone around, yet he states everything we know about physics and chemistry says that it is impossible, not hard, not an unsolved problem. It looks impossible. What's amazing is at the end of his article, he takes off the hat of a scientist, puts on the hat of the high priest of the secular faith, and says, but don't give up hope. We can solve it. Just don't give up hope. It's kind of what happened. But this is the situation of the science. And this to make it very simple, what happens is rare events might lead you towards life. Occasionally, two amino acids might link together. Occasionally, two nucleotides might form and link together. But natural processes are always breaking apart your cell. You're constantly having water molecules, thermal fluctuations, breaking everything apart. This is the challenge. Well, what's the response? Well, self-organization and natural selection. I kind of studied this as a Ph.D., and it's very interesting because self-organization's like this. If you have heat that goes into a system, you get these patterns that form. These are roll patterns. The flow of heat, energy, and matter can do this. Classic example is a tornado. That what happens, though, is that works because heat interacts with air. It makes air expand. Expanding air produces air currents. It makes sense. There's a link between the energy of the sun and the motion of a tornado. The problem is, if you look at all the energy sources on the early Earth, what they'll typically do is break apart life. Energy on the early Earth is not matched to anything useful for the origin of life, so that will not help. That is a major problem. What happens in life is you have incredibly advanced molecular machinery that forces, that will actually create high energy molecules, and those high energy molecules are useful for life. So you've got basically engines creating it. But that's really not enough, because it's not just that life has engines that produce energy in the right form, like gas in your car, but you also have information that tells the cell how to use energy. Now, why is that important? Imagine that you want to organize your house. Well, if you put gas on the couch and you set it on fire, that's not going to help you, right? Raw energy doesn't help. So you buy a robot. Now the robot takes energy and produces mechanical work, but what happens if you buy a robot, take it out of the box, charge it, and let it run loose? Not good. You have to have programming to make it work. In the same way, a cell has proteins, enzymes, that drive everything useful. And what happens, there's other proteins, they also build the structures. These proteins, as I mentioned, are chains of amino acids, and the chains of amino acids have to be in the right order, like the instructions in the software of a program. So it's the information in these chains, which are like the instructions in the program of a robot, that tell the cell what to do, because they fold in the right three-dimensional structures that do whatever. So information is essential. And this is a beautiful paper, because I mentioned that self-organization won't help you, because that's not going to give you the right energy, you're not going to have the right information. So what they then do is they appeal to something else. This is a great paper. It's Frankenstein or submarine alkaline vents. And what it says is we claim in particular that it is untenable to hold life-relevant biochemistry could have emerged in the chemical chaos produced by mass action chemistry and chemically non-essential energy inputs, and only later have evolved as dauntingly specific mechanisms. In other words, they're saying in this paper, it's a two-part paper, they say what I'm saying, these are leaders in the field, everything that happens in life happens because the machine makes it happen. Without the machines, you'll never get life. Random chemistry won't work. So they're essentially saying that the origin of life is impossible. But what do they do? What do they appeal to? Natural selection. Instead, we claim it had to have been launched simple and specific, and thereafter been forced by the scythe of natural selection to maintain the necessary specificity standard each evolutionary increment in complexity. More specifically, all the devices of life, metabolic and structural, must have been invented by it, natural selection, in situ, step by step, and while in flight, starting from the simplest possible inputs. And learning itself by trial and error which small changes, themselves occurring by chance, were useful, each incremental step in this evolution by creeps complexity building process necessarily being vetted by the system for fitting in and contributing more utility than cost. Okay, let me ask you something. Okay, we have to stop right here. What they're talking about is a bunch of chemicals in a thermal vent. That's their idea, is a thermal vent theory. Are a bunch of chemicals going to encounter natural selection? Doesn't something have to reproduce before you have natural selection? This makes no sense. You can't have natural selection before you have life. It makes no sense. And what happens is they're just saying that nature knows to select the right systems, the right chemicals. Does that make sense? How does nature know that? What's happening is origin of life researchers are invoking design. They're smuggling in a designer, but they're just calling it natural selection. That's what's really happening in the field. It's really quite fascinating. Now, you may have heard of the RNA world hypothesis. Anyone hear of the RNA world hypothesis? It's this idea that you've got these RNAs that self-replicate and evolve. Now, if you go back to the actual papers, and I went to the original papers and looked at them with a fine-tooth comb, what you find is this only works if you've got clever grad students making it work. Nature doesn't select the right sequences, the grad students do. Nature doesn't put the nucleotides together, the grad students do. So this only works with the mind behind it. And that's true with all origin of life research. Every step forward is because you've got very clever students or professors that use very clever chemical techniques to force molecules to do what they want. So again, it's the researchers that are doing the selecting, not nature. And of course, what you find is what is essential to life, as I mentioned, is information. And it's not enough to have information in your proteins because proteins don't self-replicate. Proteins don't create themselves. You've got to have the instructions in DNA. So even the simplest cell has to have DNA with the instructions to create everything else. And if you look at studies, in fact, let me just kind of show you some of the machines in life. This is just kind of an example of what copying DNA looks like. You have to have this before you have any sort of replication. Here's an example. Oh, this is, by the way, that's just the source. This is, again, topoisomerase. What this does is it untangles DNA. So it actually will take DNA, break it apart, push one strand through it, link the other strand together, and then release both strands. Because when you try to copy DNA, it tangles up. You've got to have this machine to untangle it. Without that machine, no life. That's one of the essential elements. A project I'm working on is we're looking at research in minimally complex cells. We're comparing that. Here's just several examples. We're looking at people are looking at how simple can a cell be? What is required? And we're looking at studies of self-replicating machines, like how simple is a self-replicating machine? And what you find is both studies converge and say if you want self-replication, if you want to sell a simple cell, you've got to have energy production, selective gateways, active transport, information processing, manufacturing, auto-assembly, auto-repair, waste disposal, recycling, sensors, signal processing control systems. If any of this is missing, any of it's missing, your cell is just going to break apart and go back into simple chemicals, and you certainly aren't going to have replication. So I have to ask you, let me ask you this, honest question. When you hear energy production, selective gateways, waste disposal, error correct, does that sound like design? Maybe I'm biased. Maybe I'm just a religious fanatic, but that sounds like design. So again, my thesis is that when you look at nature, laws of physics, our planet, life, it points to a creator. We are not an accident. We're created for a purpose. Thank you.
All right.
One more thing. If you want more information, this will give you lots more information, videos, books, whatever you want. Thank you.
We good? All right. Okay, wow, that was amazing. That was, okay, I gotta soak all that in. So here's what we're gonna do, okay? So we're gonna shift into a Q&A time. So we'll be setting up some mics here, and I'm gonna explain how this works, okay? So if you have a question that you would like to ask, all you'll need to do is just come up to one of these two mics, okay? So I wanna establish some ground rules for this, okay? Because questions can go all over the place. So first, please keep your questions brief, okay? There's gonna be a number of people that wanna ask questions. I wanna try to give everyone a turn, so please keep them brief, okay? The second thing is, in the beginning of the Q&A time, let's try to start with questions related to the talk, okay? And then as the discussion goes along, we can go into more tangentially related talks, okay? So we'll have Ron and Brandon over here holding mics. So if you would like to ask a question, feel free to come on down, and then maybe we'll just start with Brandon's side. And if at any point, yeah, you're ready to ask a question, just come down here and line up, okay? So again, please keep them brief and start with questions related to the talk. Thanks.
Hey, Dr. Miller.
Uh-huh.
What about all the quote-unquote useless parts of the human body, like your appendix and your pinky toe? What about those guys?
Great question. Okay, great question. What happens is when people talk about design in life particularly, they say, but wait, isn't there so much bad design? The appendix doesn't work. You've got wisdom teeth that get jammed all the time. You've got, the list goes on. The ACL is, we actually have a research program dealing with this issue. One of our researchers is Stuart Burgess, who got the award of being like one of the top engineers in the United Kingdom. And he is a world expert on copying the design from life and bringing it into engineering. What he has found is consistently, when biologists say that this is badly designed, it's because they haven't studied engineering. And when engineers look at it, they find it is optimally designed. Let me use a few examples. The appendix actually works. It acts like a fallout shelter in case your bacteria are being attacked. It hides in the appendix and comes back out when it's safe. It's part of the immune system. The appendix is not a useless remnant of our past. Oh, how about this one? Anyone ever hear our eyes are wired backwards? Okay, yeah. The idea is the photoreceptors don't face forward, they face backwards. And people think, well, that's a terrible design. The octopus got it right. Why couldn't we? The problem is the photoreceptors are constantly burning out what are called discs. Those are kind of like regions of the photoreceptor with the molecules that will interact with light. And if the photoreceptors faced forward, they would burn out. But the photoreceptors are embedded in the epithelium tissue. There's a very complex process that takes place, and it sheds off the burnt out tissue. Also, it has to have a constant supply of nutrients and energy. So an octopus is in a very low light environment, so it doesn't need the same energy source as terrestrial animals. So the photoreceptors have to face backwards to get the nutrients they need in the replenishing, or else they would not work. The ACL, you'll hear, there's a famous book, it's called, Stephen Jay Gould had it, a book called The Panda's Thumb. He made this argument. There's a guy named Nathan Lentz that wrote Human Errors. And the example he used is our ACL tears. Well, as it turns out, if you go back 100 years ago, people didn't have the same ACL problems. It's because of extreme sports, bad lifestyles. You know, if you don't exercise for like until you're 50, then you go out and play football, that happens. And if you're an extreme athlete, that happens. But again, if you look from an engineering perspective, and that's what Stuart Burgess did, is he found that the ACL is the optimal size for strength, flexibility, and operations. Because it's very compact in there, so you have to make everything small or else you will not have the mobility. What are other classic examples of bad design? Any others? Well, you get the idea. The point is consistently, when people say something looks badly designed, as our understanding of the science increases and engineers become more involved, they find that it's actually optimally designed. In fact, There's a professor at Harvard, I think it's, I'm sorry, Princeton, I think it's Professor Balick, and he talks about how many systems in life operate at close to the maximum efficiency possible based on the physics. That now biologists are assuming everything is optimally designed, and that leads to accurate predictions. Great question.
Thank you for the talk, Brian. I was raised from a Buddhist background, so a lot of it, is kind of purposed on growth. But sometimes growth becomes really hard. And, from your conversations, your discussions, you talked about, oxygen, you talked about how really rare it is. And you also talked about, biology and so forth, how it's really rare. Overall, I did some, thinking over a few weeks, and I thought about, there's a lot of randomness, right? And some of it's like good randomness, right?
Yeah.
Where it's like, it just happened because it's so rare. But I can believe in the idea of like really good, randomness happening so that things can happen. But then why does that, I guess make it purposeful for there to actually be a creator?
Right.
Because I can believe in good randomness. Okay, that makes sense because everything's quite rare. Fine tuning, LLM, so forth, everything, right? There's so many things that are like really rare. But could you like kind of give a justification for a creator?
Great question. What's really interesting, and there's so much to unpack, and you can tell me if you want to clarify any point. That's great. What happens is interesting, and I'm going to get a bit philosophical and theological. One of the big dilemmas people have found is how do you balance the idea of fate, or you might say God's sovereignty, with free will? How does that work? And what's interesting I'll speak just as a Christian. We'll jump ahead. I meant to do this later. But what happens is it's unique in that there's a sense of a sovereign God that has a plan and a purpose. And you see that purpose in life. You see that purpose in nature. But there's also freedom given to individuals to act according to their choices. And what happens is there's sort of this perfect balance between the two. Well, there's enough control for there to be purpose, but enough freedom to make real choices. In fact, what's fascinating about life is there's a professor named Michael Levin at Tufts. He's like one of the leading authorities on embryology. And he, as well as people like Dennis Noble, people like Stuart Kaufman, these leaders are saying that when you look at what's happening in life, it looks like there's real cognition. There's choices being made. It's not random. It's not even algorithmic. It's like a mind making a choice. So when an embryo develops, what happens is you can perturb it in lots of weird ways, but somehow it knows how to get back on course using incredibly creative means that seem to be doing it in a way that's more efficient than what would be possible for a computer to figure out the size of the Earth. So you see this balance of randomness and creativity and choice and so forth. Also, there's a beautiful term. It's called harness stochasticity. And stochasticity is just a different term for randomness. And what you find is that there are random mutations. And the randomness is good because what happens is life is designed with a certain logic, like your car. But you have to adjust your car. You have to move the seat up. You have to move the seat back. You might have to change the tire pressure if it's hotter or colder. In the same way, the randomness actually allows organisms to fine-tune and kind of explore possibilities to find optimal solutions. That's part of it also. No problem.
Hi, so the universe is basically like infinitely big. So it's like a lottery, but you're rolling it infinite times.
Yes.
So you're bound to get it once, right? So
yes.
I think similar to him, what is the argument for that there has to be a creator?
Yes, fantastic question. Thank you. Wonderful question. What happens is we only know of one universe. So we can say if we got everything right, that's cool. But we don't know how many planets there are, right? Because the visible universe is just the universe which is visible. We don't know how big it is. So we don't know the denominators, so you can't do probabilities. But what you can do is what might be called a more Bayesian analysis, or you might talk about conditional probabilities. If you look at all possible planets that could support life, and you look at our planet looks incredibly special even among planets that could support life. Like you could have a planet that you could support life, but you couldn't do as much science. You wouldn't have as many minerals and resources near the surface. You might not have a transparent atmosphere. Plus, our planet supports life from the equator to the poles. If you looked at all possible planets that could support life, you could make a strong case that most would support life at maybe 10 degrees above the equator, 10 degrees below, or at the poles. but the optimality for life and the capacity for cultural advancement and technology suggests that we're incredibly special even among planets that support life, which is very suggestive.
But that's only the observable known universe. But like the actual universe is, I guess you can say it's infinitely bigger than that. So why, like what's the argument against that?
Right, the point though is it doesn't matter how big it is. I'm saying that in the space of possibilities, if you look at even the infinitely large universe, all planets that could support life, you get like a histogram, we're way on the tail of how special ours is. That's the basic idea.
Thank you.
Great question. You're fun. I love this crowd. This is great.
Good evening. My name is Gigi. And I was wondering, if God designed us to be the most efficient, why do we die?
Oh, okay. Yeah. Let me kind of expand it if you don't mind. Let's just go with it, right? If God is so powerful that he created the universe and created us, why is there so much evil and suffering in the world, right? Racism and poverty, environmental destruction. Why is the world such a mess? I mean, think about the guy that like cheated you out of your car payment. Who knows? At the car shop. But that's where you have to get beyond the science, because the science will point you to a general idea of a creator, the general idea of a creator who's outside of time and space, who created us, so he's involved in the world, who seems to be personal because that creator's making choices. But that's where it ends. So to go from that to those questions, you have to get beyond science and into philosophy and history and comparative religions, et cetera, et cetera. So speaking from the Christian framework, the narrative I follow is that God created the world as good, but people had a choice to either follow God or to say, we're going to be our own God and do it our way, obey our own rules. And that broken relationship with God from people rebelling against God is what resulted in death and suffering and all that other stuff. It's like if you have a plant and you're feeding the plant nutrients, the plant grows. What if you cut the roots off the plant? What does the plant do? It dies. What if you have a car and you put kerosene in the engine? What happens to the car? We're created to be in a relationship with a loving God that gives us an eternal purpose, that gives us security and significance. But when we disconnect from our Creator, we no longer have what we're meant to have, so we replace it with other things. And trying to replace an infinite God that gives us infinite love with success or sex or whatever is like putting kerosene into the gas tank. It doesn't work and we die. That's the idea.
May I ask one more thing? So are you saying that evil is the absence of God or good?
Yes, that's exactly what I'm saying. It's very, very theological. It's like God is good. It's like what is, if a car is running the way it was designed to run, that's a good car. And sin is like dysfunctionality. Sin is acting differently from the way we're designed, which results in bad things. Evil is the bad things when we don't act the way we're designed to act. That's the idea. Thank you. No problem. Whew, this is tough. I feel like my PhD exam.
So I want to critique on your Kalam cosmological argument, where you say like before like the space-time and everything, therefore, well, actually, hold on, I'm missing my premises. Hold on. So you say like before the Big Bang, yeah, there's no space-time, matter, and all that. But then you posit God. So I want to see how you make that like leap where it's like a conscious mind, rather it could be like a necessary substance that's immaterial, that is not conscious.
Great question. Really good question. Excellent question. What I'm not doing is I'm not saying it's a deductive proof. I'm not saying that. I'm not saying this is a rigorous, logical argument that if you don't believe it, you're a moron. That's not what I'm saying. What I'm saying is it's an inference to the best explanation, that this is data out there that strongly points in the direction of a mind. Because what do you see? You see purpose. You see that time, space, matter, and energy began. That suggests that whatever started it had to be outside of time and space. Also, you see that the laws of nature were chosen for the purpose of supporting life. I'm arguing that when you see the non-material or the material come from the non-material and you see choice and purpose, that the inference to the best explanation is that there's a mind. I'm not saying there's no other possibility that people could imagine. I'm saying the weight of the evidence it points in that direction in a meaningful way. And then when you combine that with the design and the origin of life, you combine that with other sources of information, that it's a strong case. I'm not saying it's such a rigorous, logically proven argument that if you don't believe it, you're a moron. That's not what I'm saying. I'm saying here is evidence, it's compelling, it convinced me, it convinces others, and I present that to you for exploration and pursuing the truth. That's my idea. No problem.
Hi, I'm Tamila. So I have a couple questions, but you focused a lot about the origins of life and how that supports a creator. Can you talk a bit about evolution and natural selection and how
Sure.
that might coexist, or what that might have to do with a god?
Sure. And I generally try to avoid this topic because there's so much cultural baggage. I remember I was at a meeting once, and a professor came up and he said, well, thank you for telling me I'm not going to hell because I believe in evolution. He was being sincere. So there's like a lot of emotional baggage. So I want to touch this delicately. And let me just say, there are a lot of very sincere Christians who believe God used evolution as part of the process. I respect what they're saying. Here's what's problematic. If you look at Darwin's idea in the way he understood it, you see, Darwin didn't have his ideas out of a vacuum. What happened was he was very much influenced by the materialist tradition. His grandfather, Erasmus Darwin, read the poem I mentioned by Lucretius. He wrote his own poem called The Temple of Nature, where he was basically trying to bring the atomistic materialist view into Europe. So Darwin was shaped by that. Darwin was part of the Freethinker Society in Edinburgh. So Darwin was shaped by this materialist view. So his biography portrays himself as this open-minded, objective observer, but that's not what his private journals show. And when he used the language of natural selection, it was interesting, because William Paley was a natural philosopher before Darwin, and he wrote the famous watch argument. If you go through the forest and you find a watch, you see the watch has many interacting parts that were put together for a purpose that points to a mind in the watch. And people said, well, you see the same thing with life. But Darwin used Paley's language, he used his examples and even his cadence, and Stephen Jay Gould talks about this, but he replaced God with natural selection. So natural selection, the way he framed it, was deliberately a way to remove God from creation. That tradition of evolution is more problematic, both philosophically and scientifically. In fact, there was a meeting in the Royal Society of London. It was New Trends in Evolutionary Biology, and you've got leading evolutionary theorists, people like Gert Mueller, people like Dennis Noble, people like Jim Shapiro, and they basically said that framework for evolution doesn't work. It'll give you small changes, but not big changes. So that idea is collapsing. So there are other ideas of evolution that are more design-based. Like, for instance, I mentioned Michael Levin, and there's actually an article that came out recently by Kaufman, Marshall, and Seigart. And basically it's talking about how you look at life and you see cognition, you see a mind at work. So there's ideas of evolution that can be more consistent with the belief in God, that God used evolution as part of his toolkit, so to speak, and people can work that in. But there's other versions that are more problematic. The key question, here's the key question. When you look at the human body, is it an accident? Is it unintended? If you rewound the tape, as Stephen Jay Gould said, would you get something completely different? Maybe intelligent life would be dolphins? Or is this the product of a mind, and then that mind, through some way, shape, or form, at some time, in some way, brought about what that mind wanted? That's the key issue. And then within the Christian community, some like evolution, some don't. There's honest divisions about that. But the key issue is purpose in mind, which is what I'm arguing for. That's helpful?
Can I ask another? Okay, real quick. Is there any scientific evidence to support why specifically the Abrahamic God and why not,
Oh, great question.
Buddhist, Hindu God?
Great question. That is not something that can be answered by the science. The science gives you the general idea of a personal God outside of time and space. For me, and for anyone who's answering that question, I'll just speak about Christianity. The question is the resurrection. So when you look at the central claim of Christianity is that Jesus Christ came to earth, he was God in the flesh, he performed miracles, he cast out spiritual powers of evil, and then he died on the cross and rose from the dead. So for my quest, that was the question I was looking at historically. And there's a lot of books that talk about how if you apply the standard methods of history to the empirical data, the Gospels, external sources, that claim seems very, very, very strongly supported by the evidence. If anyone's curious, there's books by Lydia McGrew, like Testimonies to the Truth. That's Lydia McGrew. You've got other people like Ian Bauckham and Gary Habermas who talk about this. I think Gary Habermas is finishing like some massive tome. So for that question, for me, the historical evidence was significant and also experience. I've seen people healed of sickness in Jesus' name. I've seen just sort of supernatural things. I feel like I should speak with a Pentecostal. No, and then even people's testimony. Like I know a person who's from Africa who came from a very different culture, and Jesus literally appeared to her in a dream and said words she didn't understand and had to ask Christians to explain words like hallelujah that she didn't understand. So what you're seeing, and this is a promise that you see like in the Gospels, the early writings about Jesus, is Jesus said, he or she who seeks will find, whoever knocks on the door will be open. So for me, the problem isn't intellectual. It's not evidence. The problem is our will. Do we want to serve God with all of our hearts, or do we want to be our own God? That's the question. Do we want to create a God that we like, or do we want to accept God for who he is? That's the first question people have to ask. So, no problem.
Hi, Professor. My name is Jing Lan, and one of my major is history.
Uh-oh.
So, no. Yes.
Okay.
So but not the history problem.
Oh, okay.
But I want to ask one question. Do you think it's really meaningful to prove or try to disprove the religion through the reason, science, or the logic? Because I know there's a lot of Christian masters or Christian scholars in the history.
Yeah.
They do not agree to use science or academy to prove whether God exists, like St. Augustine or the Martin Luther. Martin Luther said, if you are Christian, you need to dig out your eyes of reasons. Mm-hmm. Yes. And I also talk with this problem with my father. And whenever I talk something about the logic or the science to try to prove or disprove whether God exists, he said, stop. What you say is science or the logic, but what you say is not about the religion. The religion is the thing of spirit or the mind, but not the science.
Sure.
So what do you think of that?
Well, you didn't see how you get questions this hard. I mean, my goodness, I've been bamboozled. This is hard. That's a fantastic question. I literally was talking about this with friends the other night too. This is a huge, huge debate taking place. And I'm a scientist, I'm a physicist, I'm not a theologian, I'm not a philosopher, I'm not a historian. So let me do my best, okay? Much greater minds than mine. But I believe you're right. I believe it is a very impoverished faith which is based purely on an intellectual examination of evidence. That is not biblical, that is not life-giving. The faith is basically based on the person of Jesus Christ. Jesus said, my sheep will know my voice, another voice they will not follow. But I believe God has given invitations. Like I can invite you to a party and you can accept that invitation or you can reject that invitation. God gives different invitations for different people. Thomas is a great example. Thomas wasn't there when Jesus appeared. This is, I believe, in John 20. And what happened is he was the twin, right? So he was a twin who probably was confused. People probably confused him with his brother all the time. So you can imagine what he was thinking. So Thomas said, I will not believe unless I touch the wounds in his side and the wounds in his wrist. Jesus appeared to him. And what Jesus did is he allowed him to touch the wounds in his side and the wounds in his wrist. He didn't say, Thomas, shame, 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 faith is blind. No. Thomas was the empiricist, and Jesus gave him what helped his rational mind. For other people, it's the love of Jesus in their hearts they experience. For other people, it's a healing. For other people, it's a direct encounter. Here's one of my favorite examples. Anyone hear of Craig Keener? Oh, never mind. Anyway, he is a world-class scholar of the New Testament. And the way he became a Christian was these missionaries who weren't terribly courteous basically gave him a very cheesy presentation of faith. And he said, well, how do you explain dinosaur bones? And they said, Satan put them there to deceive people. Now, I'm not a theologian, but I don't think that's necessarily the best answer. I think dinosaurs are cool, but that's just me. And then they said, you better listen to what we're telling you, or you're going to go to hell. Really gracious, thoughtful. Well, Craig went back to his house, and then the Holy Spirit hit him, and he felt God's love for an hour, and he became a Christian. And later, he learned the intellectual arguments. In fact, he helped me through my faith crisis. For me, I thought the Bible was unhistorical. I thought that it was all made up. He showed me that the historical evidence behind the New Testament was overwhelming. I'm a scientist. It really helped me. The science helped me a lot. I'm a scientist. For other people, God will reach out to you in the way that's best for you. But the challenge, again, is not the knowledge. It's not the means. It's your will. Do you want to believe in God who is real, or a God of your own making? Do you want to serve your own agenda, or do you want to honor and serve God? That's the question. And God can reach out to you in whatever way is most appropriate.
Before our next question, all of you guys that have questions that are still waiting, I want you to hold on to those. Just want to make a quick announcement. So this will be our last one of the live Q&A portion. So for those that are lined up, you can still ask Dr. Miller your questions. He's going to be hanging around here. But we'll just have our last question here, and then I'm going to come up and wrap up our program real quick.
Hi, I'm Mari. I was just wondering, what is the natural selection's argument for that all living things seem to have a motivation to keep surviving and keep staying together? Because if molecules randomly came together, why do they bother sticking together if it doesn't really matter in the end?
What happens is that theory is going down the toilet. What happens is natural selection functions, like when people invoke natural selection, it's not like a real process, it's like a demigod. There's a great book, it's by Michael Behe, it's called Darwin Devolves. And he identifies what actually happens in evolution. Like people have looked at finches, and they looked at the genetic diversity in finches. They looked at the genetic diversity in cichlid fish. They looked at the genetic diversity in the model organisms, whatever you want to mention. And what they find is that even mutations that are beneficial, that are, let's say, relatively random, typically degrade proteins, they degrade function. They cause de-evolution. Like if you have a car, and someone hits your car and it damages the front door, that might prevent you from being carjacked. That's beneficial. But it doesn't matter how many times people run into you, you'll never turn your car into a submarine. This is the challenge. So this idea of random mutations and selection doesn't do much. But also you see on the horizon, phenotypic plasticity. There's several people look at phenotypic plasticity. And what people have found is that the adaptation that looks really cool isn't random. Like you see these cichlid fish with all this variation, but you see the same variation in every lake. And it's not random mutations, but what they're finding is organisms sense the environment, and when there's the right environmental triggers, there's pre-programmed responses. It's like a juvenile cichlid will eat something hard, its jaw is different. So the evolution, the adaptation is not random. A lot of it is either pre-programmed. There's natural genetic engineering where genetic changes aren't all random, but some of them are more targeted. But what you find where it's fairly random is really modest changes. In fact, if you look at leaders in the field, people like Charles Marshall, people like Eric Davidson, what they say is if you look at mutations that affect early development, it's harmful. Like can you tell me a single mutation that's altered an animal in some significant way that could lead to a large-term change? Yeah, good luck. If the evolutionary framework were true, we should have a newspaper column with all the changes we see every single day. So this whole idea of natural selection is going out the window. Now, your average biologist doesn't know this. You have to go to the special conferences with leaders in the field, but that is going out the window. So people are looking to much more design-based models of adaptation and evolution. Like look up Michael Levin. Oh, I shouldn't say, I'm gonna get him in trouble. Yeah, just go to that site I showed you and there's gonna be interesting papers on it. It's really dangerous because I mention these professors and then they get harassed by people to shut up. So I have to be careful who I mention. Is that it?
Yeah, so
Thank
let's
you.
give a round of applause for Dr. Miller. Okay, so if you still have a question, and I see a number of people here lined up, so just want to assure you, you will have a chance to ask Dr. Miller. He's going to be hanging around here for a little bit as well. And maybe, tonight you're on some part of your faith journey. Like, I don't know what it was that brought you here. Maybe it was a friend. Maybe you got a flyer. And maybe some thoughts were stirred tonight. And maybe you're wondering, like, okay, like, what more? What's next? And I want to tell you some steps that you can take. So one, if you came with a friend, right, keep talking to that friend. Like, hey, what did you think about that? Hey, I have some other questions about these things. I want to encourage you, keep talking about these things. The second thing I want to encourage you is outside in the foyer here, there's going to be a couple of tables for different Christian groups and campus fellowships here. I want to encourage you to get connected with these groups. So yeah, Dr. Miller talked a lot about the science and evidence for design, right? Well, another question you can ask is, who is this designer? What are they like? How can I know them? And those are important questions that we need to ask, because at the end of the day, like Javon said earlier, these are the questions that's going to determine how we live our lives. And so I just want to encourage you that at these different fellowships, they are great places to ask those questions. They would love to get connected with you. So they're going to be right outside over here. So if you want to keep talking and hanging out with Dr. Miller, he's going to be here. With that, we'll also have some snacks and refreshments outside. So just as a little token for thank you for coming out. So thank you again for spending your evening with us. And yeah, see you around.